Bueno,
Ahí todo el mundo llega ahí, está teniendo desayunando, no llega a desayunar con la carreritas.
La puerta abierta. Okay, let's get started. A lot of people. I guess my topic today is not very hot. Sorry, we have a problem with the screen. Okay, always working now. Sorry, we have a complicated technology arrangement, but now everything's working. So, yeah, I had a role in shaping the program of this conference, and they wanted to add some methodology to the conference. And I know that you guys are primarily interested in practice and professional issues related with profession and application. But anyway, we need to have a talk on methodology, so I hope it's not too painful. I'll try to make it as light as possible. So the issue I want to talk to you about today is maximizing impact, maximizing research impact in the context of trying to convince politicians, public health institutions, health decision makers, and so forth. So this idea came about because I'm going to have a meeting with this guy in a few months, the Ministry of New Zealand, and I have a PhD student. She has developed a treatment or an intervention program for kids with severe feeding disorders, and we want to sell it to the government so they fund it, and more clients can benefit from it. So this guy is our target. This upcoming meeting is forcing us to become current on New Zealand politics, trying to figure out how they are influenced and how they make decisions. Maybe this video can give you a sample of how politics work over there.
Absolutely, we always take something away from every meeting we have. Ah, yes. Good day. Thank you.
very useful.
It's the right in our country because of the TPPA and celebrate our rights and our freedom. I do that for our country.
We have. We have.
Okay, so this is an important lesson about things work over there. Anyhow, we would use another strategy other than throwing dildos. Interestingly, the guy says "goodo" and then says "thanks." If you listen to him, you can understand. Anyways, from the preliminary meetings we've had with people like the CEO from Autism New Zealand, in reality, their decision making is primarily driven by evidence, by the standards of evidence, international standards of evidence that have to do with mainstream clinical outcomes standards, of which you have a sample in the slide. Decision makers typically put a lot of weight in things like meta-analysis, randomized controlled trials, and other group-based studies of which we are not very educated on. So I thought I would take the opportunity to talk a little bit about these designs that really carry a heavy weight in the decision-making process of politicians and such, and so that's essentially the goal. When we get into the meat of methodological aspects, it might be a little dry, but keep in mind that there is an applied goal to to the comments I will be making. Here you have some evidence of impact of these various approaches to clinical evidence. You can see here that meta-analysis are the kind of study that produces the highest impact in terms of citations, which is an indication of impact within academia. Meta-analysis, for those of you that are not familiar, is simply a reanalysis of a number of group studies in order to come up with an aggregate or an estimator of effect size of a particular intervention. And they are followed by randomized control trials. There are group studies where you have a group that is not receiving the intervention and a group that is receiving the intervention, and the allocation of clients to groups is randomized. So these are essentially the highest standards of what we should be aiming for if we want to influence these people. Unfortunately, single-subject experimental designs are typically packed in this category, case reports, which have minimal impact, at least within this measurement. But if we use other measurements of impact, like for example, well, these citations too, but if we translate this estimation of impact to our field, this is actually based on medical treatments, but this would be an equivalent in our field. This is a study that we published a few years back, a meta-analysis on early intensive behavioral intervention, and this is the cumulative count of citations over the last few years. If we compare it with the JAMA publication that has had the highest number of citations that year, you can see that the difference is by many-fold inferior compared to what we got with the publishing this particular meta-analysis. And when you look at other measures of impact that are more close to things related with services that people are getting, we get similar results. So, for example, this meta-analysis that we published a few years back, it has been cited in the health policies of a number of health insurance providers in the States, actually some of the major insurance providers. So allegedly, our work have had impact in indirectly in over 100 million subscribers of these health insurance policies. So a great impact that can be obtained using these studies. So given that they are so influential, it probably would be worth it to know a little bit about these randomized controlled trials and the mainstream approaches to synthesizing evidence in mainstream clinical sciences. So the first clinical trial was conducted by a British guy by the name of James Glynn in the 18th century. And I thought, this is as good as any to give you an idea of how these studies work. This particular doctor was studying scurvy for the British Navy, and he was on board the Salisbury and picked 10 clients or 10 patients with scurvy. At the time, it was not known that it was a deficit in vitamins that caused scurvy. So he tried a few different things. He took 2 of the 10 guys and gave them cider. Another 2 were given vinegar 3 times a day. Then another 2 got salt water, seawater. I guess that's convenient treatment if you're on board. Then another 2 got lemons and oranges. And finally, another 2 got sulfuric acid. So, the results of that particular group was not reported, unfortunately. Anyways, the individuals that received the lemon and the oranges quickly improved. You have a quote there from the original book published in the 18th century. And after a few days, they were fit for duty and they were much improved. Although this, of course, study is very primitive, but it shows us some of the main features that a clinical trial has. Clear inclusion criteria, concurrent multiple interventions, is group-based as opposed to case-based, although in this particular example it was only 2 individuals per group. And the focus is on evaluation as opposed to analysis. Then and even now, clinical trial is no good to develop new treatments, but simply to evaluate known treatments. And the 5 treatments that Lynn evaluated were already known at the time, but haven't been evaluated systematically. Another feature that are not in this particular example is placebo. You should have an additional group that is not receiving anything or is receiving some kind of a fake intervention, and randomization was also missing. It shows he assigned the individuals to the group based on his own criterion, and also the public health impact, as opposed to what you may think, was none at the time. It took actually another century before the British Navy would lemons and apples, lemons and oranges in their fleet. This is the first real randomized control trial to evaluate streptomycin on tuberculosis. It was done in the 40s in the United Kingdom. You can see that clinical trials have increased over the last few decades enormously, and they are close to take over any other design for the purposes of clinical evaluation. However, case reports and single-subject experimental designs are typically packed in that category, are still growing strong. They're even higher. Another feature that these clinical trials have acquired that really put our behavior analysis in a disadvantage is the use of statistical methods to evaluate significance. And due to the work of Fisher and others starting in the 20s and 30s, researchers started using significant tests to evaluate experimental effects. And journal editors at the time very quickly adopted this approach to evaluate experimental effects. You can see that this is the number of articles in some few American flagship journals that were not using any statistical methods to evaluate effects. You can see there were 56% in the 40s and only 11% in the 60s. And of course, this trend has continued to be almost 0% nowadays. This shows the same thing. You can see that the use of ANOVAs and t-test increased starting in the 30s, and other measures, non-statistical approaches to evaluating evidence went down. So the statistical summarization, if you wish, of effects is also a standard that is very commonplace, and we're not able to produce a behavior analysis as we use visual analysis typically to assess our data. Here you can see that clinical trials are at a point of overcoming case reports just by number of publications. This is in case of all therapeutics, including medicine, and you see a similar pattern in the case of psychology. So let's look into the specific features of clinical effect evaluation, and let's try to see if we can deliver in terms of meeting that standard or compromising into that standard, keeping in mind the methodological approach that is most prevalent in behavior analysis. So let's start with using groups, comparison groups or control groups, and the use of randomization. Here is this review article was published in the New England Journal of Medicine, and they evaluated a number of medical treatments, and they compared those who were randomized and non-randomized. And I'm not going to get into the detail, but essentially, out of the 50 or so studies that were evaluated, only in 7 cases, the non-randomized study offered really different or really departed from the average effect size that was observed in the randomized studies. And interestingly, most of the studies that were not randomized, they underestimated the effect. And only 2 out of the 50 or so overestimated the effect, which would be the bias that you really want to avoid. You don't want to get into a situation where you attribute evidence to a treatment that is really not effective. So if you really think in terms of this data set, at least, not randomizing it has a deleterious effect in very few occasions.
So, can you repeat what was the conclusion?
The conclusion is that only in a fraction of cases, at least if we look at medical therapeutics, non-randomizing in a clinical trial, remember randomization involves random assignment of individuals to groups, would overestimate the effect, which is really what you don't want to happen. In a few cases, you would underestimate the effect. In most cases, you would get essentially the same effect. And also the probability of bias, as this graph shows here, is minimal when you have medium to large effect size of an intervention, which is what you would expect in most treatments. So the evidence we have available, at least if we look at medicine, is that randomization is really not that important. I'm not completely discarding it, but there are ways to empirically evaluate how important it is, and the evidence suggests that it is in fact not that important. Let's look at the controlling by control groups, which is another standard of randomized controlled trials. This time we have some evidence-weakened behavior analysis. These are studies that have evaluated early intensive behavioral intervention, both using group studies and weakened subject studies. Between group studies, you have a control group and you have a group that is receiving early intensive behavioral intervention. The control group is typically receiving some kind of intervention, maybe special education, or maybe yes, whatever the parents want to do. It's very hard to have a clean control group in these kind of studies. Then in the weakened subject studies, you will have the same plans you evaluated before AIDI and then after EIDI, or throughout different stages throughout the EIDI process. You can see that in average, these are effect sizes. The effect sizes are very similar. 1.3 in the case of between group studies and 1.0 in weakened subject studies. Again, we see underestimation trend or bias in the weakened subject studies, which is a safe bias. You don't want to overestimate effects. This kind of bias by design may not be universal. I mean, what I just showed is relevant to behavioral intervention. But if we do the same analysis in another program, like TEACH, for example, we find the opposite pattern, where the weakened subject design is actually overestimating effects. And you can see that the effect sizes are much smaller. So when you're working with very small effect sizes, it is possible that developmental trends are biasing your result, in which case weakened subject studies would overestimate effects. By developmental trend, I mean that a child, even without any intervention, may naturally improve in certain skills. And if you are working with very small effect sizes, those developmental trends can actually produce a significant bias. In EIDI, because the treatment effects are larger, those developmental trends are less of a concern. Or at least that's the way to interpret this data set. So different programs, different direction in bias according to design, experimental design. So some take-home messages about randomization. The value of randomization can be empirically evaluated and may vary across programs, and the lack of randomization doesn't seem to involve a very high risk of bias, at least based on the evidence that we have available. Let's look at another feature: longitudinal effects and sample size. And sample size is another limitation of behavioral studies under the eyes of health decision makers. We use tiny sample sizes, and they think that our studies are just pilot studies. You may have worked 5 years in a series of single-site experimental designs, and then they would still regard your work as pilot. There are some features of behavioral studies that completely differentiate a single-subject experimental design, or even a group evaluation of early intensive behavioral intervention to studies conducted using a standard randomized controlled trial design. In this graph, you can see a bunch of studies. I believe it's the last 10 studies or 15 studies published in the New England Journal of Medicine that were randomized controlled trials. And you have sample size along the x-axis and duration of treatment in terms of hours of intervention along the y-axis. And what you can see is that there's a complete dissociation between the two groups of studies. Medical randomized controlled trials are extremely short in duration in terms of actual intervention, and their sample sizes can be extremely large, up to 1,000 or more than 1,000 clients, as opposed to behavioral studies where you have enormously long interventions, sometimes over 1,000 hours of intervention, and then tiny sample sizes that rarely are more than 10, 15, or 20. So we have these two very different approaches, and these really should have an impact in the way we evaluate evidence. However, that hasn't happened yet. So in a medical clinical trial, you would have something like this. You have an intervention that has a relatively quick effect, and then you evaluate in specific time points. So you have short intervention duration, relatively fast effects. In a behavioral intervention, you have extended duration and gradual effects. And up to now, we have not acknowledged this distribution pattern of data over time in the way we assess clinical effects. But we should, because there are already statistical models of estimating the sample size that you need to achieve a particular effect size according to the number of repeated measures. So if you increase the number of repeated measures in your design, you can really lower the number of clients that you need to demonstrate a particular effect size under certain statistical significance criteria. So this is something that we haven't been done yet. I mean, if you look at the few early intensive behavioral interventions group studies that have been published, they are not longitudinal. I mean, they don't use repeated measurements over time. So we really should embrace that approach in order to maximize effects and include in our studies estimation of sample sizes that sort of demonstrate that you don't really need that many clients if you have many measurements over time. So essentially what you see here, to achieve a given level of what is called statistical power, if you only have one measurement, in this particular example, you would need over 100 clients. If you have 24 measurements over time, you would only need 6 clients. So that's an important consideration in terms of analytics and how the study is designed or conceived. So we, in the University of Auckland, we are actually trying to use that approach to marry single-subject experimental design and clinical trials. I'll just give you a very brief summary of what we are trying to achieve. We are evaluating a few very simple behavioral interventions on the level of activity of clients that live in residential homes, all people that for which sedentary behavior is a concern. They spend 90% of their waking time sitting, or even more sometimes, and that of course causes all kinds of health problems. So we are trying to get them to move. To do that, we are using the fitness bands and accelerometer that they wear in their thigh that would monitor their level of activity and whether they are sitting or walking or upright. And the fitness band will give them a little prompt if they are not moving for X amount of minutes. And the threshold varies from client to client. So with this type of study, we can have lots of measurements over time. This is just standard multiple baseline design, but we can still use this data to analyze clinical effects using a longitudinal clinical trial sort of analysis, as I was suggesting before. So in this particular case, what we want to do is to, if you wish, marry both traditions of clinical evaluation, single subject experimental design on one hand, and then clinical trial design on the other hand, and hopefully that approach would maximize evidence. So some take-home messages. The longitudinal nature of behavioral analytic interventions should shape how clinical outcomes are evaluated. That hasn't happened yet, but we hope that it will very soon. Time series recording a lot of measurements over time within a experimental conditioner phase allows for relatively small sample sizes, and you can still use very sophisticated statistics to evaluate evidence. And in conclusion, non-randomized within subject and between group longitudinal designs may be an ideal compromise between single subject experimental design and clinical trial designs. Let's look at another standard of the mainstream evaluation of clinical evidence, which is the potential for statistical synthesis. As I was showing before, clinical trials have completely embraced statistics to evaluate and to summarize clinical effects. And in that respect, we are disadvantaged. We don't have, or at least didn't have until relatively recently, sophisticated models to evaluate clinical effects in single subject experimental designs. However, there are a few things that have happened over the last few years. The renowned statistician Hedges developed a model for evaluating or obtaining effect sizes based on single subject experimental designs. There have been 4 or 5 studies published by this team over the last 3 or 4 years, and I think it's a promising model. It has positive and negative features. But instead of getting to the boring formulation of the model, I conducted some simulations to test if the model actually works as you would expect. And remember that the bottom line here is to come up with a number that would summarize what we would otherwise conclude based on visual analysis of data, which is what we are used to. So here you have the effect size, this metric of effect size that they've developed. Remember that effect size of 1 unit is considered moderate to large, and anything about 1 or 2 is considered a large effect, probably compatible with a clinically significant effect. So here you have, I just use multiple baseline designs for the sake of this particular example. This would be the reference study where you have a sound, multiple baseline design, little variability, little variability and a relatively large effect and immediate effect of the intervention. And I compare it here with another good design where you have decreasing trend during baseline and then an immediate change in trend direction after intervention. This will be a situation where visual analysis will tell us that this is a sound intervention because the trend is going against the direction of treatment during baseline and the trend direction changes during the intervention. However, the model is blind to those kinds of subtleties of visual analysis and really penalizes these changes in trends. And you can see that the effect size goes down to below 1, whereas here you have an effect size of almost 8. So, you know, the model is still not perfect, but it has a few positive features. If you were to have opposing trends, like an increasing trend during baseline, which you don't want to have, and then a decreasing trend during intervention, which of course you don't want to have, to suggest that the intervention really has no real effect, the model really catches that and gives you a negative effect size. Whereas here, although it provides a very small effect size, still a positive effect size. I mean, there's a potential for a favorable clinical effect. Other features that the model is not very good at, this is a situation where you would conclude that you had a sound experiment where you have simply some transition data, where after you implement the intervention, it takes a little bit of time for the behavior to pick up. And those trends have to do primarily with the way in which you aggregate data. I mean, if you have 1-hour sessions, you are less likely to have these transition trends. If you have 5-minute sessions, you're more likely to get those transition trends. But that has nothing to do with the real effect of the intervention. So it shouldn't be penalized in the statistical analysis of a single subject design. And what we see here is that the model actually penalizes those transition trends quite a bit. If you compare it with this reference data set, the effect magnitude has been reduced by more than half, as you can see in the estimator up there. So again, not a perfect model. This is another situation where you have delayed effect. As you may remember from methods classes, if you have a delayed effect during a multiple baseline design, that sort of injures the experimental demonstration in this particular design, and that's actually penalized by the model, as you can see when you compare the estimators of the reference data set on the left and the delayed effect on the right. So that would be a positive feature. However, when you look a little more in detail into it, and you have an effect that in a multiple baseline design starts exactly at the same point for all individuals or contexts or behaviors, which you don't want to have, it suggests there is something else happening that is affecting all individuals or all behaviors. The model actually bonifies or augments the effect size in that particular scenario. So, you know, there are positive features to it and other features that are not so positive. This will be a positive feature when you have 0 baseline. Most statistical models have trouble working with 0 values. However, with this particular model, you get a similar effect size no matter if you have simply a baseline with low variability or a baseline with 0 values. So that would be a positive feature of this particular model. So there is a potential that we will have a technology to summarize evidence of single subject experimental design in the near future, but we're not there yet. I mean, what I just presented is probably the most sophisticated model that is out there, and as you can see, it has some shortcomings to it. There might be non-statistical approaches to summarizing visual analysis interpretations, and we are working on one of them. This is a study that I'm developing with a mathematician in Canada, and it's not published yet. But what we've done is take hundreds and hundreds of functional analysis data, published data sets, and feed it into a neural network algorithm, and see if the algorithm can interpret the data. And we use as a reference for the algorithm to work a set of rules that Louis Hagopian and colleagues developed a few years ago. We updated those rules so the neural network can actually work with them because they were loosely defined in the original study. And after doing that, we've been able to predict, to get almost perfect interpretation of functional analysis data sets using this neural network model. And we use really, what you would think of almost confusing data sets where the interpretation was not clear. For example, when you're comparing an automatic function with a multiple control situation where you have more than one operand controlling the behavior, and a situation that is frequent, as Dr. Hanley was discussing today when talking about synthesized contingencies. And so far, on the basis of over 100 functional analysis of either automatic control or multiple control, we've been able to get the algorithm to guess the proper interpretation in 100% of cases. So this sort of process can help to develop, if you wish, a calibration of interpreting behavioral data sets. And it can really not replace visual analysis, because of course we want to continue for clinical purposes to visually analyze the data sets, but develop quantitative benchmarks and strategies that can summarize numerically our visual analysis process and sort of sell our strategies and our methods to people that are more used to numbers as a way to summarizing and interpreting evidence. Because, you know, visual analysis, if you talk to an epidemiologist and you tell them that you are visually analyzing your data, they won't take you seriously. So some take-home messages. Potential for numerical summarizing, yet being consistent with visual analysis standards. There is a potential. We're not there yet. Statistical synthesis is possible with models like the one by Hedges that I described, and they are really relevant because they open up the potential for meta-analysis and other syntheses that we know, as I was describing before, have a great impact, not only in academics, but also in policy making, which is what we're interested in. Synthesis has the additional advantage of advancing research, not just consolidating it. And this is a side comment that I want to make. When you synthesize evidence, you may discover new things that may lead to future empirical research. And I have a couple of examples of that. This is from a meta-analysis that we did a few years back, and we were able to identify effect trends based on the amount of treatment. So here you have receptive and productive language in kids with ASD that were exposed to either low intensity, middle intensity, or high intensity intervention. And you can see what we call a dose-dependent effect. So gradually you see a greater effect when the intensity of the intervention is greater. And you see the same here for adaptation outcomes like the Binland, those kinds of tests. And this was established only after reanalyzing a number of studies, after synthesizing a number of studies. By looking at these studies individually, you wouldn't get this information. So you really get new information that could be useful, for example, for treatment planning, resource allocation, and other things. This is another example from a study that we published earlier this year. Here, what we evaluated was the effect sizes that you get of a behavioral intervention when you use a behavioral functional assessment prior to the intervention, or you did not use a functional behavioral assessment before the intervention. And what we saw was quite interesting. I'm not going to get into the conventions of the data of the graph, but essentially when you compare no treatment to a treatment that is based on a functional behavioral assessment, you get a large effect size. But when you compare nothing with an intervention that is not based in functional assessment, you get 0. So it's like not doing anything at all. So that was an interesting find, and you wouldn't be able to appreciate these kind of results in individual studies. You only get that kind of finding after reanalyzing many studies. So synthesis has a potential for creating new information, not just consolidating it. So some more take-home messages. The identification of intervention parameters important for service planning can be obtained through synthesis studies, and the potential for summarizing and synthesis has the potential for summarizing massive amounts of sometimes cumbersome bodies of literature. And the last thing I wanted to talk about has to do with another approach to synthesizing evidence. And this is more closer to clinical practice. And these are practice-oriented synthesis models. And the students and I have developed a couple of these over the last few years. But I'll talk about just one of them that one of my doctoral students is developing. What she's trying to do is to validate assessment and intervention models for kids that have severe feeding disorders and are being fed by a nasogastric tube. And if you're not familiar with what a nasogastric tube is, I have a video here that shows a little bit. So the problem with these kids is that they typically have some kind of medical problem early in their, as babies typically, and then they are provided with these tubes and fed that way, and then they get used to it before they even develop the skills that they need to feed themselves, and eventually they become tube dependent, and they would refuse oral feeding. And then the families will just keep feeding them through the tube for years on end. So that's the nasogastric tube. Not very nice. So this is the model that she's developed. The model is inspired both by evidence. There's a lot, literally hundreds of studies that support the various steps in the model, but it's also guided by clinical standards or ethical standards, if you wish. The model is designed in a way that less restrictive interventions are tried before more restrictive interventions are tried. So essentially, we start with an antecedent analysis. We present different kinds of foods and vary them based on particular dimensions, for example, volume, texture, or utensil that is used to present the food. And we evaluate which dimension creates the greatest compliance or the greatest acceptance, and then we use that dimension to increase oral consumption. So for example, if small volumes are producing a lot of acceptance, we increase or fade in the level of volume gradually. So that's more restrictive or manipulative interventions like reinforcement-based interventions or escape extinction procedures are tried later on in the model. So what she's trying to do is come up with a bunch of clinical cases that validate this model. I can show you an example of that here. This is the case of a client that really benefited from the antecedent manipulation of volume. You can see that there's a lot of this antecedent analysis, and you can see that volume produced a lot of acceptance. So we will use volume as the start point for the intervention, and the fading level of volume. So this particular client, these would have been her itinerary through the model. There was no mastery criterion in terms of acceptance of food at the beginning, So then we tried the antecedent analysis. The antecedent analysis was successful, and that led to the end of treatment. If that wouldn't have been successful, we would have tried more restrictive approaches to intervention. So this is another strategy to synthesize evidence, sort of aggregate all the evidence into a model that a practitioner can use and is evidence informed. So more take-home messages. Synthesis can take the form of evidence-informed clinical decision-making models. As shown, the synthesis models can be evaluated. She's, conducting a study to validate this model. And so far, we have clients that have gone through all of the possible permutations of the model. So that's good because you validate every element in the model. The approach to synthesis minimizes the gap between research and practice and service model. So this approach to synthesis is really close to practice as opposed to something more abstract as a meta-analysis would be. So just some final remarks. Maximizing impacts requires a synthesis technology, and greater use of this technology is needed to compete with mainstream outcome research. And we are not familiar with this technology. We don't use this technology. But if we want to convince the New Zealand politician, we really need to learn about it. Gracias. So if there are any questions, everybody happy? No questions? Okay, thank you.